Hi guys, so in this video we're looking at exercise 14.4, which is solving maximum and minimum problems. By the end of this class you should be able to apply your knowledge of maximum and minimum to a variety of different situations. Okay, so in these types of questions, they may also be called optimization or modeling. When you're solving for a maximum and minimum value of a function in these types of questions, the first thing that you should do is write an equation for the value you are trying to find. i.e., if they're asking you to find the maximum area, you write an equation for area. If you want to find the maximum perimeter, you write an equation for perimeter. Try and write these equations so that you only have one variable in them. Then, use this equation to find the local maximum or minimum values for your equation. i.e., derive your equation, put it equal to 0 and solve for that unknown value. Once you find your unknown, substitute it back into your original equation and solve for the maximum and minimum value of what you're asked to find, i.e. the maximum minimum area, maximum and minimum volume. Okay, let's look at an example question. A typical question is something like this. You have 40 meters of fence enclosed in a rectangular garden along the side of a barn. What is the maximum area that you can enclose? So we're looking for the maximum area here. All right, so let's look at this question. I'm going to draw out a diagram so it gives me a better idea of what I'm looking for here. So here's my barn. And I want to find the maximum area enclosed. All right, so what are we told? We're told that the perimeter of the fence is 40 meters, and I know I want to find the area. Step 1 is to write an equation for the area of the shape you're looking for. You are looking for the area of a rectangle. Therefore, your area is equal to the width times the length. Now we want to write this equation where we only have one variable. I know that the perimeter of the fence is 40 meters. I'm going to call my width x, which means that my length will be 40 meters minus those two widths, so minus 2x. Once I have my lengths and widths written in terms of one variable, x, I substitute these into my equation for the area. That means my area is equal to x times 40 minus 2x. From here, I want to find my maximum area. If you see the word maximum in your question, I want you to derive your equation and put it equal to 0. The first thing we're going to do here is just expand out these brackets to make my derivation a little bit easier. So my area is equal to 40 times x minus 2x squared. Okay, so to find my maximum area, I derive my equation for the area. This gives me 40 minus 4x. From here, I'm going to put my equation equal to 0 and solve for x when we have a maximum area. So putting my equation equal to 0 and solving for x gives me 4x equals 40. Now to solve for x, I divide both sides by 40 and I get x equals 10. That means that when x is equal to 10, i.e. your length is equal to 10, we will get the maximum area for my enclosed fence. To find my area now, I substitute my value for x into my original equation and solve for the area. This gives us a equals 10 times 40 minus 2 times 10. Multiplying this out gives us a is equal to 10 times 20. My area is equal to 200 meters squared. So we're saying when we have a width of 10 meters and a length of 20 meters, we get the maximum area enclosed. In all of these equations, you're going to do them the exact same way. Write an equation for what you're looking for. Write this equation with only one variable, i.e. in my case, x. Derive the equation, put it equal to 0. Solve for the unknown, substitute it back in. Okay guys, having gone through the example, I now want you to complete questions 2, 3, that's questions 2, 3, 4, 5, 7, 10, and then our challenges are question 13. Okay, if you're unsure of question 13, there is another PowerPoint going through how to solve this equation attached to this assignment. So that's exercise 14.4, questions 2, 3, 4, 5, 7, 10, and your challenge, if you want to try it, is question 13. If in doubt on question 13, just read through the solution. Please remember that with all of these questions, you're following the same set steps. That is, write down the equation for what you're trying to find. Then, solve for the derivative of the equation when it is equal to 0. Find your unknown and substitute back in.